All right, tonight what we're going to be learning about is graphing. And graphing is key to any science class. A lot of times we're given a lot of data and we have to interpret it. And in order to interpret it, we need to do it in a simplistic form, often using graphing. Graphing is a visual diagram, and by visual you're going to be using your eyes so you can actually see it to illustrate the relationships between two or more variables. And variables by definition are something that varies. Okay, so it's changing. Hopefully it's changing, or maybe it's not, and that's actually what you want. But the graph will show you whether it is changing or not visually. There are a few components that all graphs need. The first is the title. The title is always written with the dependent variable first versus the independent. Yes, I know in English class you always want to be creative. In science class we just wanted you to tell us the important information. What did you study? What versus what? And you always put it at the top of the graph. Okay? The other things that you need to know is your dependent variable. And the dependent variable is always written on the y-axis. And the dependent, to be dependent, means that you are responding to a change. That is different from the independent variable. The independent variable is what you directly changed. Okay, the dependent variable changes because you changed your independent variable. So the example I always give in my class is if I were to increase how often I run per week, how would that affect my mile time? I am independently changing how often I run, and the dependent variable would be how long my mile time is. The independent variable is always written on the x-axis. And very important, as in all science classes, you must remember to do your units. So the example to the right, these are always the examples that we like to use, and they help visually put the notes into a representative model. So a ball is dropped from several distances above the floor in meters, and the height it bounces is measured in centimeters. Okay, so create a title and write the variables on the appropriate axes. So the first thing that I need to do is figure out what did I directly change. At least that's how I feel that it's easiest. So what did I directly change? The distance in meters that it was dropped. And what changed because of that? The height the ball bounced. Okay, so I am going to put them on their correct axes so that what I directly changed would be your independent variable. So I'm going to write dropped height down here. Once again, you need units, so it's going to be meters. Okay, and because I dropped the ball at different heights, the bounced height changed, and that would be in centimeters. Okay, so this would be your dependent variable, and this would be your independent variable. One way to remember which one you want to put the dependent variable is remembering the phrase, why are you so dependent on me? In addition, you can fill in a D for dependent on the y-axis. The title should then be your dependent versus independent. You can think of it as I read left to right in English, so I'm going to read left to right with my graph. So it's bounce height versus dropped height. And I'm hoping you write a lot neater than I am. It's harder with a stylus than I'm sure it is with a pencil. Another thing that you need to understand and remember is that all graphs should have some sort of a slope. And the slope is a representation of the change, how y changes for every change in x. We use it as the abbreviation or symbol of m in both math and science class. Okay, it's also known as rise over run. So this would be an equation that you would like to know. So your slope, which is abbreviated as m, is your rise over run. So your change in y over your change in x. Okay, those are all represented by this formula. Okay, an equation for a straight line. We will be dealing with a lot of straight lines or linear relationships in this class, and the equation is one that you should be very familiar with. Y equals mx plus b. Y is your y value, x is your x value at that given time, b is your y-intercept, or where it crosses the y-axis, which is talked about down here, and m, as we already talked about, is our slope. Most of the time in this class it should be 0, but it not always is at 0. Okay, so here's an example. Graph and find the slope of 4, 3, and 1, 2. So what I'm going to do is I'm going to go over 4, 1, 2, 3, 4. I'm going to assume in this graph that it would be increments of 1. This is your x value, and this is your y value. So over 4 up 3 would be at here. Over 1 up 2 would be here. So I graphed it, and I'm going to form a line. Okay, and then to do my slope, I am going to take my change in y over change in x. It doesn't matter if you take 4 minus 1 or 1 minus 4, but you just need to be consistent. If I go 4 minus 1, then I need to do 3 minus 2. Okay, so I'm going to do my change in y, which would be 3. So I'm going to take 3 minus 2, divided my run, which is my x-axis, and that would be 4 minus 1. So if I solve it and reduce it, it would be 1 over 3. So my slope would be 1 over 3. In this case, our value didn't run in at 0, and depending on what relationships you're studying, that would make sense. So for example, if you never studied for a test, you probably wouldn't necessarily get a 0, but you would probably get some sort of score. It just wouldn't be as good as if you had studied more. All right, making graphs, very, very important, okay? So these are the various steps that you're going to want to follow when you are making a graph, okay? So you're always going to, not all graphs, make sure you understand go in at y-intercept. You kind of have to look at the relationship and see if it should or not. First, you want to find the difference between the high and low points, and then you're going to divide the number of boxes. So I'm just going to do a straight out example problem. So it's really important though that you keep your increments equal to one another. So let's just follow these directions and use it in the example that I give you. So using the data below to create the graph. Okay, so here's our data. We are directly changing the temperature. So temperature is going to go on this axis. Okay, remember your degrees Fahrenheit. And then we're going to do ice cream sold on the dependent axes, because depending on temperature, the ice cream will change. Ice cream, and then millions of cones. Once again, you should write it all out, but I'm trying to just use a stylus, so it's a little bit more difficult. All right, so the first step it says is find the difference between the high and low point for an axis. So I'm going to deal with temperature right now, so I'm going to take 90 minus 70, okay, which equals 20. Then I'm going to follow step 2, divide the total number of boxes, which I've already counted. There are 10 boxes along this axis. And so I'm going to divide my 20 divided by my number, which is 10. So each increment should be an increase of 2. Okay, so now I'm going to label it. You don't need to label all of them. I would recommend labeling the first guy, which would be 70, is that guy, and then maybe every 10. So 72, 4, 6, 8. So this would be 80 right here. And then 2, 4, 6, 8. So this would be 90 right here at that bottom. Otherwise, sometimes it becomes too clustered. Now, you're more than welcome to write everyone, but sometimes it just becomes too clustered. So the next thing I'm going to do is the y-axis. So I'm going to take my difference once again. So 6 minus 5, which equals 1. And I'm going to divide by how many boxes, which is 10 in this case. And so I'm getting 0.1. So I'm going to start with 5 down here, is that axis. And then at the very lowest point, and then I'm going to increase by 1. So I'm going to do for this guy every 5. So 1, 2, 3, 4, 5. So this would be 5.5. And then 1, 2, 3, 4, 5. So this would be 6.0. And there you go. You have your graph labeled. The next thing is one of the hardest parts, and I would really pay attention to this guy because a lot of people had difficulty doing this, okay? It's when you are requested to draw a line with given a specific slope, okay? So I'm going to follow these steps, but I'm just going to go straight out to the example again. All right, so graph a line with a slope of 7 grams per milliliter. I know that 7 grams in this case is going to be, the grams is going to be my y-axis. Why? Because it's rise over run, so my rise would be grams, and milliliters would be my run, so running would be on the x-axis. So I know that grams is on the y and milliliters is on the x. Or you could look at the graph that's already labeled. So the first thing that we need to do is write the equation of the line. So I am going to assume, because I don't give you a y-intercept, that my y-intercept is actually 0. So my equation of a line is y equals 7x. Okay, you can put in the units, it's probably beneficial, but right now I'm just going to write 7x. Okay, so now we have to graph what it looks like. So I'm going to follow my steps. Using the equation line, choose any value of x. In this case, because I see a 0 for this guy right there, okay, I'm going to choose 0 for my x. So if y, I'm going to plug it into my equation. So y equals 7 times 0, which means y equals 0. So I solve for my y, which is 0, and then I now need to plot these coordinates. Well, my coordinates were 0 for my x, and 0 I discovered was my y. So I'm going to put it on as 0, 0 right here. Now, in order to do a line, all you need to do is get 2 data points. So my next data point I'm going to do is, let's say, make my x equal to 2. So I'm going to have y equals 7 times 2. Well, I realize if I do 2 and then I fill it in for my x, I would be all the way of y equal 14. The problem is that that's not on the graph. So that is not a good data point, and I'm going to have to start again. So the next one that I'm going to do is, let's say, make it smaller, and I'm going to make my x, which is my milliliters, equal to 1. So I'm going to do y equals 7 times 1. So if I plug it in, I've got 1, and I'm going to go up 7, because y equals now 7. So my coordinates would be 1, 7. So I'm going to dot at 1 and up 7. Okay. Now I followed steps 1 through 4. And now I just need to do 5, which is connect the dots. So using a line or a ruler, a straight edge, you should connect the dots. And that is a really bad line, but it relatively would have the slope of 7. All right, now we're going to talk about best fit line. And a best fit line is just a line, which means a straight line. And in science, because we're always talking about relationships, we never want to connect the dots. It's a general form. It's a general relationship. So you don't want to take these individual ones. You just want to look at the overall picture. You need to use a ruler, okay? So don't be drawing like I've been drawing and just kind of free draw it. You need to actually use a ruler, and it's always to discover the relationships. So what you want to do is you always want to visualize, kind of roughly get the best average. So we're going to look at the other graphs to the right and figure out what we would have done for the best fit line. I've already drawn a best fit line for all of these. Now what you need to do is you need to draw them. Now if you look at it though, I could have actually drawn, let's say for example, this bottom one, I may have drawn it just a little bit more up. I may have drawn it just a little bit more up or higher. And that doesn't mean that mine is necessarily wrong versus yours being right. It just is what it is. So that's the problem with you guys freehand drawing it, is because your line might be a little bit different, which means that our slopes are a little bit different. That's why I always encourage using computers, because computers will always give the best average that it possibly can. But what you want to do is you want to get an average where they're below and an average where they're above, and then kind of just fill in a line in between them where it's the best average. Okay, reading a graph. These are going to be talked about throughout this entire year, these relationships. You have a direct relationship, indirect, and inverse. Direct, most people know it's as one goes up, the other goes up. The indirect is as one goes down, the other goes down. The equation for both of those is a line. The only difference is that for an indirect relationship, you have a negative slope. An inverse relationship, on the other hand, is a little bit different. Inverse means that as x increases, so as you go further to the right of your graph, y decreases proportionally. So this has an inverse relationship equation. Looking at the graphs, which you do need to know, the direct relationship is one goes up, the other goes up. Okay, and this would be an equation of a line. An indirect is one goes up, the other goes down, and this would have a negative slope. And then your inverse is where you're going to have, as one increases, meaning x, y is decreasing disproportionately, meaning not as a line. So today we're, I guess, done with graphing for chemistry, and you are going to be expected to understand all of these different relationships, and I would focus especially on understanding how to graph knowing the slope of a line.